This is problem number 87 on page 743. In number 87, you're trying to solve for which one of these has the smallest molar solubility given their KSP values and the chemical equations. So in 87A, it's very, very easy because you have CaF2 compared to BaF2. Because they both dissociate into the same number of ions, you just compare their KSP values. The KSP for CaF2 is 4.0 times 10 to the negative 11th, and for BaF2, KSP equals 2.4 times 10 to the negative 5th. Because this number is much, much, much larger, that means this is more soluble in water. So the question asks, which has the smallest molar solubility? Calcium fluoride would have the smallest molar solubility in this case. In part B, however, it's a bit more complicated because we have calcium phosphate as compared to iron phosphate. In this case, your KSP equals 1.3 times 10 to the negative 32, and in this one, KSP equals 1.0 times 10 to the negative 22. We can't just compare these two values because these two substances break up into different numbers of ions. So what we have to do in both of these cases is solve for the molar solubility and compare those values. Calcium phosphate dissociates into 5 ions. 3 calcium 2 plus ions and 2 phosphate 3 minus ions. If we set up our ice table, both begin at 0, this becomes 3x, this becomes 2x, and to solve for KSP, it equals Ca2 plus cubed times PO4 3 minus squared. KSP value equals 1.3 times 10 to the negative 32, which equals 3x cubed times 2x squared. 3x cubed is 27x to the third, and 2x squared is 4x squared. So when you multiply those together, you get 108x to the fifth equals 1.3 times 10 to the negative 32. So to find the answer to that, you divide by 108, and then you take the fifth root. So if you plug that into your calculator, you get that X, which is the molar solubility of calcium phosphate, is equivalent to I don't know.